We have one more presentation to go, and then the fire chat. Both will be with Jenya Meydbray from PVEL, the famous lab that several of the presenters already have mentioned. So let's start with Jenya's talk.
Hi everyone, my name is Jenya. I'm with PV Evolution Labs, or PVEL, and today we'll be talking about bifacial modules in the lab and in the field. Quick agenda today, I'll introduce PVEL and our product qualification program, talk through a few trends in bill of materials and module construction that we've seen over the years. Of course, we'll get into the topic at hand, which is bifacial yield on trackers at our outdoor testing facility and a PID case study from the lab, and then we will wrap it up. So first, about PVEL and our product qualification program. We've been operating for a little over a dozen years now, founded in 2010 in California. Our services include reliability and performance testing of modules in the lab and of modules, inverters, and energy storage systems in our outdoor testing facility, both in California. We offer data services, including a forecast report that forecasts forward 3 years, PV module cost structure, price, technology, and form factor. And we offer field testing, specifically electroluminescence imaging of operating assets, including EL imaging from drones. In 2021, PVEL became a member of the Kiwa Group based in the Netherlands. Here's a snapshot of Kiwa's capabilities in the solar space. Kiwa also owns a company called PI Berlin as of recently. It's a large company founded in 1948, over 10,000 employees. Won't go into the details of everything here. This shows a quick snapshot of how PVEL works with both upstream and downstream partners. We sit in between the buyers and the sellers. We perform our product qualification program, which is a comprehensive testing program. The same program is executed on every bill of material and every manufacturer's. And then we share results with our downstream partners to help our manufacturers get qualified for projects and for approved vendor lists. Really, the goal of the product qualification program since we launched it in 2012 is to provide independent reliability and performance data to buyers and to highlight and recognize manufacturers and specific products that excel in testing. As I mentioned earlier, we've tested over 500 unique bill of materials from over 50 manufacturers over the years. One important point is that every time the program is executed, the bill of materials and the module construction are witnessed. So there is a trust but verify activity up front to ensure that the bill of materials and products are indeed independently observed and then randomly selected. And all the PV modules are subjected to the same testing program, which can be seen here. I won't go through all of the individual test legs, but as you can see, it's the intent is to be comprehensive and really target all of the aging behaviors that a PV module can exhibit in the field, in addition to providing PAN files and IAM measurements for energy forecasting. So switching gears into some of the bill of material and module construction trends that we've seen over the years. As I mentioned, the product qualification program was originally launched in 2012. For every single program we execute, we know the bill of materials and independently witness those for the modules. So we have a pretty good feel for what's entering the US market. Module designs from 2015 to 2021, as you can see, was primarily monofacial until 2018, and then bifacial started to pick up steam, and you can see bifacial has really taken over. I think this is no surprise to most of the folks on this call. Module area similarly has gone up and up and up and up, especially in 2020. It took over. Most modules were over 2 square meters. In the past year, we even have a lot of modules over 2.5 square meters in size. So very large modules need very large equipment to test them. We've similarly seen the cell technology evolve over the years. Of course, the ALBSF cell technology has been completely phased out. As of 2019, we still saw a little bit, but really nothing since then. PERC has really picked up steam and taken over the market as of 2017, 2018. And as you can see, the small blue bars at the top show N-type entering the market, but still a pretty small market share. So we see a lot more press releases about N-type than actual product shipping into the country. However, I do believe this is about to change. 2022, early 2023 may be the time of where N-type really starts to pick up serious market share. Similarly, on the number of cells per module, this also has continued to change over the years. Back in the day when we walked the halls of Intersolar Munich, we saw 60 cell and 72 cell modules and mono and multi in every single booth, and they looked more or less the same. That definitely is not the case anymore. As of 2019, most modules were half-cut cells, and this light blue portion of other, meaning not 120 cells and not 144 cells, is growing in market share steadily. One interesting thing we've seen over time is on the encapsulant suppliers. Over the last 5 years, since 2016, we've seen a single supplier take up over 50% market share, and the rest is split across 28 different companies. So there really is one very dominant encapsulant supplier. In terms of the material types that are used, we saw EVA only until 2018 pretty much, when we started to see a little bit of bifacial, a little bit of glass. We saw POE enter the scene, and POE really has started to be present in most modules nowadays. In fact, almost half of modules have a mix of EVA and POE. A lot of modules have POE twice, and then a minority of modules just have EVA and EVA. So switching gears again and discussing bifacial yield on trackers. As I mentioned in the introduction, PVEL operates an outdoor laboratory in Davis, California. It's called PVUSA. It was originally built in 1986. I think it's one of the world's oldest PV research facilities. PVEL took it over in 2011, and we have a 10-acre area there where we test a lot of different PV modules, inverters, batteries, trackers, have a lot of side-by-side testing. We had a Department of Energy funded outdoor bifacial study. It was conducted on 10 rows of Nextracker's single-axis NX Horizon tracker. There were 2 different albedos evaluated, as you can see in these photos here on the right. On the top, there is a white artificial plastic sort of cover. On the bottom is just a natural grass cover. There were 9 different PV module brands participating. You can see them listed out here. And these were full 1500 volt strings, so that is unique. Oftentimes, you see bifacial studies on individual modules. I think that is missing the impact of mismatch, which on a bifacial system I think should be more substantial than on a monofacial system because of the non-uniformity of the backside irradiance. Additionally, all of the modules had bifacial and monofacial strings of the same technology. This was in order for us to calculate the bifacial gain, we needed to have the monofacial reference point. All of the modules in this study were initially flash tested. This is critical because one often sees bifacial gains listed in a vacuum, and it doesn't say, doesn't state often what that's in reference to. Typically, I think it's in reference to nameplate. However, flash test doesn't always equal nameplate. In fact, we see it rarely exactly equals nameplate, which is okay. On 3 different manufacturers here, you can see the average flash test relative to the nameplate for the monofacial and the bifacial. For manufacturer B, that spread is almost 3%. So the bifacial gains would already be tilted in one direction by 3%, which is a very substantial bias offset. When that's what we're trying to measure is probably less than 10%. So 3% is a very big percentage of the overall. These are flash tests out of the box. So the other consideration is you could flash test after light soaking. In the data that I will be presenting today, we'll be looking at flash test data out of the box as the baseline for calculating bifacial gains. So switching gears to some results here, we did have a number of different technologies present as well. So you can see across several different months, this is a while ago when the system was initially installed. We see the kilowatt hours per kilowatt peak, or in this case, watt hours per watt peak installed, or of the systems installed, presented here for different modules. As expected, the heterojunction glass-glass module is the highest performer with 8.5% higher bifacial gains than the lowest performer, which was a PERC glass-glass module. And 4% higher than the average. This data here is shown on the natural ground cover, so not the white albedo. The white albedo was, of course, even higher, several percentage points higher. Switching gears to a potential induced degradation case study here. As part of the product qualification program, we do this PID test. It's at 85-85, so damp heat conditions at maximum system voltage for 192 hours. We've done this on all of the bill of materials that have gone through the test, so we have pretty good data dating all the way back. Ever since 2014, if we just look at all of the data that's gone through the test, it looks pretty stable. The median doesn't really bounce around. The test has always had a substantial number of outliers. Some modules really perform poorly in this test. It seems there's a couple of years where maybe it was improving a little bit, but then it gets worse again. So overall, pretty much relatively stable median performance. So what can we learn from this data? Let's start peeling it apart in ways that are specifically relevant to bifacial modules. So if we separate glass backsheet from glass, we can see there is some difference in performance, but still nothing compelling. The glass backsheet looks fairly, again, the median looks fairly stable over the last 5 years. More outliers can be seen in the glass bombs, and overall, there's a little bit more variability. So digging into this glass data one step further, if we separate out modules with PoE only from modules that have EVA in the module package, that's when you start to see some interesting signals. Modules with EVA, bifacial modules with EVA, perform substantially worse in PID than bifacial modules that have PoE at least on the back. PoE is typically, when it's mixed with EVA, it's in a single module, it's typically the back encapsulant, and EVA is on the front. That's because the back surface of a bifacial cell is very sensitive to PID degradation. The static charge builds up on the back of the cell and probably has an impact on the back surface field that is inside the silicon. So we've seen quite consistent results over the last 2 years, where modules with EVA are performing substantially worse than modules with PoE. Nevertheless, we are still seeing modules with EVA in the lab. So wrapping things up, modules have changed substantially since PVEL was first founded. Here's an image of a Suntech module from 2010. This is the year we started. It's a 190 watt module. I think most developers would not be pleased with a 190 watt module. It has it's a 1.5 meter by less than 1 meter. It's less than 15% module efficiency, and the temperature coefficient of Pmax is 0.45%. Quite a bit worse than today's modules. So we've seen bill of materials change dramatically over the years. We've seen module construction change dramatically over the years. I think we're going to see factory locations evolve. I think we're going to see new manufacturers enter the market. Expected service life in the utility scale sector has increased to 35 years pretty typically, at least in the US. There are a lot of variables in module design, and not all modules are created equally. I hope I showed you that today. It's critical that something like the product qualification is used by developers when evaluating modules for your approved vendor lists to protect your assets from premature degradation. PVEL is here to help you. Please feel free to reach out to me or anybody else on the PVEL team. This is necessary. This step is necessary to achieve the terawatt manufacturing scale that this industry is going to need to see over the coming years. And finally, one quick plug for the PV module reliability scorecard. We release this every year. This year was the 8th edition. There were some interesting things to highlight. 25 manufacturers were named, meaning they were top performers in at least one test. We saw an improvement in thermal cycling results. We saw a reduction in damp heat results. So it's a little bit mixed overall. 26% of the BOMs, a quarter of the bill of materials had at least one failure. Please read the report. It's a free download. It has its own microsite, as can be seen here, modulescorecard.pvel.com. A lot of great information there. That's all free for you. So with that, let me wrap it up and thank TaiyangNews and Michael, and look forward to the conversations. Thank you.